Good day, guys. Today, I'm going to continue my last discussion on volumes of solids of revolution by integration, applying cylindrical shell method. So volumes of solids of revolution using cylindrical shell method. This method is an option to the circular disk or circular ring method. It is used if the appropriate volume element is parallel to the axis of revolution. Let us consider this region, bounded above by y equals f of x, below by y equals g of x, on the left side by the vertical line x equals a, and on the right side by the vertical line x equals b. So this is the plane region to be revolved about this axis of revolution. If this is the type of region that is to be revolved about this axis of revolution, the appropriate element is vertical, happens to be parallel to this axis of revolution. Expected when this region is revolved about this axis, of course, this area element will also revolve and will form a cylindrical shell. So let's see. So when this region is revolved about this axis of revolution, this is the solid that is formed. Okay, so along with this solid generated, we have also the volume element generated, and that is cylindrical shell. So let us have the volume of this cylindrical shell. This cylindrical shell has the following dimensions. So for the inner cylinder, we have R sub I as the radius. And then for the outer cylinder, the radius is R sub O. And when you add these two, divide by 2, so gives us the mean radius. And that mean radius is the radius of this shell. Okay? So, and this shell, cylindrical shell, is actually the difference between what? Between this outer cylinder and this inner cylinder. Okay? And this cylindrical shell has a height of h, and then the thickness of the shell is dt, which is actually outer radius from this point to this point minus inner radius that is from this point to this point. So that is the thickness of the shell. Okay. So for the volume of the cylindrical shell given by dV, where V is the volume of the solid of revolution, and this is equal to the difference between the volumes of the outer cylinder and the inner cylinder. So getting pi square of the outer radius multiplied by the height minus for the inner cylinder pi multiplied by the square of the inner radius times the height. So factoring out pi, we get pi times outer radius squared minus inner radius squared multiplied by the height h. Expressing this in factored form, we get r sub o plus r sub I multiplied by r sub o minus r sub I, then times pi, then times h. So if I will divide this by 2 and then multiply by 2, then rearrange, we get this. Okay? So 2 times this is equal to r sub o plus r sub I. And then this r sub o minus r sub I. So we put it at the last part of this product. Okay? And this is the average radius of the shell. Okay? So that is given by r. So getting 2 pi r times h, and this r sub o minus r sub I is the thickness, dt. So this gives us the differential of the volume. Again, where V is the volume of the solid generated. For the volume of the solid of revolution formed, we have volume is equal to 2 pi times the integral from a to b rh dt, where a and b are the limits of the original region to be revolved. Okay? And then R, we have mean average radius of the cylindrical shell. So that's again mean or average radius of the cylindrical shell. H is the height of the cylindrical shell, and dt the thickness. Okay? So let us have the following examples. Find the volume of the solid generated when the plane region bounded by the given curves is revolved about the indicated axis. Y equals x squared plus 1 and the x-axis from x equals -1 to x equals 2. Axis of revolution, letter A, x equals -1. Letter B, x equals 3. So let's begin with the points of intersection. Y equals x squared plus 1 with the x-axis. So that is with y equals 0. So when y equals 0, we get x equals, x squared plus 1 equals 0, getting imaginary roots, therefore no real solutions. If x equals -1, we have y equals -1, quantity squared plus 1. So that is equal to 2, getting -1 to as a point of intersection of this parabola and the vertical line x equals -1. What about if x equals 2? So getting y equals 2 squared plus 1, and that is equal to 5, getting 2, 5 as their point of intersection. For the parabola, y equals x squared plus 1. So its standard form is x squared equals y minus 1, getting vertex 0, 1, and this type of parabola opens upward. Okay, so let's start with the axis of revolution, x equals -1. So this is the plane region to be revolved. Plotting the given points. So we have 2, 5, -1, 2. So -1, 2, 2, 5. Then the vertex of the parabola is at 0, 1. So here is the parabola, whose equation is y equals x squared plus 1. And then below by the x-axis, then on the left side of the region, we have x equals -1. On the right side, x equals 2. So this is the region to be revolved. The appropriate element here is vertical. So when revolve about the line x equals -1, expected, since this is parallel to the axis of revolution, the volume element that to be generated or that can be formed is cylindrical shell. Okay? So with height y higher here minus y lower happens to be 0. So getting x squared plus 1 as the height. And mean radius is given by x minus, so this is x here, minus -1. So x plus 1, okay? Which will be useful later. So let's now revolve this. So this is the solid generated when revolved about the line x equals -1. So that's the solid. So along with this, the area element, when revolved about x equals -1, cylindrical shell is formed. Using cylindrical shell method, so we have dv equals 2 pi rh dt. R here is, as I mentioned, x minus -1, so x plus 1. So this is from here, this is x from the y-axis to this point is x. So x right, which is x minus the axis of revolution, -1, so getting x plus 1. What about the height? The height is y higher minus y lower. So that is x squared plus 1 minus 0, getting x squared plus 1. So the volume is given by 2 pi integral from a to b rh dt, where dt is dx because this is vertical. So getting 2 pi integral from -1 to 2. So original region runs from -1 to 2. Then integrand x plus 1, x squared plus 1. Then this is multiplied by dx. So let's multiply this integrand. Okay. So we get x cubed plus x squared, this part, then plus x, then plus 1. Integrating, getting x to the 4th over 4, then plus x cubed over 3, plus x squared over 2 plus x, evaluated from -1 to 2, then multiply by 2 pi. So at the upper limit, we have 2 pi times here, 16 over 4 plus 8 over 3 plus 4 over 2 plus 2 minus the value of the same expression when x is -1. So getting 1/4 minus 1/3 plus 1/2 minus 1. Okay, so adding these four terms, we get 4 plus 8 over 3 plus 2 over 2. So that plus 2 plus 2, I mean. So that is 32 over 3. And then this, -7 over 12, getting the difference. So that is 45 pi over 2 and multiplied by 2 pi. Okay, so that's the volume of this solid. What about letter B? If the axis of revolution is x equals 3, so the plane region to be revolved, same region. So the only difference, axis of revolution. So this is the line x equals 3. The appropriate element is vertical for this type of region. So expected, since this is parallel to the axis of revolution, cylindrical shell is formed. So solid of revolution. So let's revolve about the line x equals 3. So that's the solid generated. So along with this area element will also revolve, of course, forming this shell. Okay. Using cylindrical shell method, we have dv equals 2 pi rh dt, where dt is equal to dx because this is vertical. Radius is 3 minus x, while the height is x squared plus 1. So again, the radius of the shell is this x right. This is 3 minus x. So this is x right. Okay, so 3 minus x. And then for the height, y higher minus y lower. Y higher is what? So y higher here of the element, x squared plus 1, y lower is 0. So getting x squared plus 1. Okay. Then of course, dt again is dx. So volume is 2 pi integral from a to b rh dt, getting 2 pi integral from -1 to 2. So this region runs from -1 to 2. Then integrand 3 minus x multiply to x squared plus 1 quantity, then dx. So let's multiply, getting negative x cubed. This is negative x cubed plus 3x squared, then minus x plus 3. Integrating negative x to the fourth over 4 plus x cubed over 3. Cancel with this 3 here. Negative x squared over 2, then positive 3x. So when x is 2, so this expression is equal to what? -4. Negative 2 to the fourth over 4 is -4. That is 16 over 4. So negative, then -4. Then this is 8. This is -4 over 2, -2, plus 3 times 2 is 6. Minus, at the lower limit, when x is -1, so this is -1/4, -1, then -1/2, -3. So this gives us 8, while this one, -19 over 4. Getting the difference, multiplied by 2 pi, we get 51 pi over 2 cubic units. So that's the volume of this solid. Let's have number 2. Find the volume of the plane area bounded by y squared equals 4x and y equals 2x minus 4 when revolved about letter A, y equals 4, and letter B, y equals 0. So again, let's begin with the points of intersection of this parabola and the line, solving them simultaneously by substitution method. So let's substitute y equals to x minus 4 here. So getting 2x minus 4 quantity squared equals 4x. So expanding 4x squared minus 16x plus 16. Then that is equal to 4x. Simplifying 4x squared minus 20x plus 16. So dividing by 4, we get x squared minus 5x plus 4 equal to 0. So factoring the left side, we get x minus 4, x minus 1 equal to 0. So then x equals 4, one of the roots, the other root is x equals 1. When x is 4, we get 8 minus 4, so that is 4. So we have a 0.44. When x is 1, we have negative 2. So we have 1, negative 2. But this is not in the first quadrant, so we're not going to include this in our discussion. What about intersection of the x-axis and the parabola? So 0 squared equals 4x, 0 equals x, so x equals 0, therefore we have 0, 0. What about the x-axis and the line? Y equals to x minus 4. So we have 0 equals to x minus 4, so x equals 2. So getting 2, 0. This parabola, y squared equals 4x, is already in standard form. Getting the vertex 0, 0 opens, this parabola opens to the right. So let's first consider axis of revolution, y equals 4. So this is the region form. Plotting the points, we have 4, 4, 0, 0, 2, 0. The parabola passes through 0, 0, and 4, 4, while the line passes through 2, 0, and 4, 4. Then the x-axis is here. So the region in the first quadrant is this. So axis of revolution is y equals 4. So when revolve here, by the way, the appropriate element is horizontal. Okay? And that happens to be parallel to this axis of revolution. Expected cylindrical shell is the volume element formed. So let's now have the solid generated. When revolve about the line y equals 4, so we'll have a reflection here, and this is the solid generated. So along with this, so the area element will also revolve, forming cylindrical shell. Using cylindrical shell method, dv equals 2 pi r h dt. R is 4 minus y, so that is the radius, mean radius of the shell. So that is axis of revolution minus here, this point is y. Okay, so the element is from this x-axis is y. So any point along this element is y. Okay, so that is 4 minus y. Okay, and then the height, x right, that is the line, minus x left, the pink one, which is the parabola. So 1/2 y plus 2 minus y squared over 4. So that's the height. dt equals dy, since this is horizontal element. The volume is given by v, which is equal to 2 pi integral from a to b radius height dt. So getting 2 pi integral from 0 to 4. The original area runs from 0 to 4, y values, because this is horizontal. Then 4 minus y, the integrand, that is the radius. Height is 1/2 y plus 2, then minus y squared over 4. Okay? So this is the height. So let's multiply this. So getting 2y plus 8 minus y squared, then minus 1/2 y squared minus 2y plus y cubed over 4. So 2y and negative 2y are cancelled. So getting 1/4 y cubed minus 3/2 y cubed, minus 3/2 y squared plus 8, then dy. Integrating, we have y to the 4th over 16 minus y cubed over 3. 3 is cancelled, getting negative 1/2 y cubed plus 8y, evaluated from 0 to 4. So getting 2 pi multiplied by this. So this is at the upper limit. The value of this is 256 over 16. So again, let me check. 4 raised to 4 divided by 16. So that is 16. Then minus 64 over 2. That is 32. So negative 32. 8 times 4 is positive 32. At the lower limit, everything is 0. So this gives us 32 pi cubic units. So that's the volume of that solid. Letter B, same region to be revolved, but this time to be revolved about the x-axis, y equals 0. That is the x-axis. So the appropriate element is, again, horizontal, and that is parallel to this axis of revolution expected. Cylindrical shell is the volume element generated. So for the volume of solid of revolution, for the solid of revolution, so we have this solid. Okay, so that's a solid. So the element also will revolve, of course, forming the shell. So using cylindrical shell method, volume of this shell is dV, which is equal to 2 pi RH dt. R is y minus 0. So the radius is y. Any point along this element is y minus 0. So that radius is y. The element is x, right? That is 1/2 y plus 2 minus x left, y squared over 4. So this is the height. dt is what? dy, because this is horizontal. So volume is given by 2 pi integral from a to b of RH dt. So we have 2 pi from 0 to 4. The area runs from 0 to 4, the area to be revolved. So we look at the y values because the element is horizontal. So again, 0 to 4 the limits. Radius is y, and the height is negative y squared over 4 plus y over 2 plus 2. Multiplying y inside, getting negative y cubed over 4 plus y squared over 2 plus 2y. Integrating, getting negative y to the 4th over 16, y cubed over 6 plus y squared. Then multiplied by 2 pi. So this is evaluated from 0 to 4. So getting 2 pi. At the upper limit, we have negative 256 over 16 plus 64 over 6 plus 16. Everything is 0 at the lower limit. So getting 2 pi times, so this is 16 negative. This is 32 over 3 plus 16. And then giving what? 64 pi over 3. Okay, so that's the volume. 64 pi over 3 cubic units. What about if the region to be revolved is bounded by the following curves? Y equals 3x squared minus x cubed, and the x-axis from x equals 0 to x equals 3. Axis of revolution, that is x equals 0. So we have x equals 3 here for the second one. So let's begin with the points of intersection. Y equals 3x squared minus x cubed. So getting the intersection of this with x equals 0, meaning with the y-axis. So that is y equals 0. So getting 0, 0. When x is 3, so getting y equals 3 times 9, then minus 27. So that is equal to 0. So getting 3, 0. If y equals 0, that is the x-axis. So getting 0 equals 3x squared minus x cubed. Factoring 3x squared minus x cubed, we get x squared times 3 minus x. The roots are x equals 0 and x equals 3. When x is 0, so we get 0.00. When x is 3, we have 3, 0. Okay? So let's discuss a little 3x squared minus x cubed, which is equal to y. So getting the first derivative, we have 6x minus 3x squared equating to 0. To get the critical numbers, we have 3x, 2 minus x equals 0. Hence, the critical numbers are 0 and 2. So critical points, when x is 0, we have 0. Then when x is 2, y is 4. So getting 2, 4, and 0, 0 as the critical points. Which of these 2 points is a relative mean or a relative max, or neither? So let's see. Let's use second derivative test. Y double prime is equal to 6 minus 6x. When x is 0, y double prime is 6 minus 6 times 0, 6. That is equal to 6, greater than 0. Therefore, 0, 0 is a relative minimum point. When x is 2, y double prime is 6 minus 6 times 2, that is equal to negative 6, less than 0. So 2, 4, therefore, is a relative maximum point by second derivative test. So for points of inflection, we equate the y double prime to 0. Y double prime is 6 minus 6x equated to 0. Negative 6x equals negative 6. Therefore, x equals 1. When x is 1, from the curve, we have 3 times 1 minus x cubed. So 3 times 1 minus 1. So getting 2. So the point of inflection is 1, 2. Okay? So this is the trace of the curve together with the other lines. So first we plot the important points. So these are the important points. The curve will pass through 3 points, minimum at 0, 0, maximum at relative maximum at 2, 4. Point of inflection at 1, 2. So, and at the x-axis will pass through this 0, 0 and 3, 0. So this is the curve and that is the region to be revolved. So which is above the x-axis under this curve. So the appropriate element is vertical. Since the axis of revolution is the y-axis, and it so happens that it is parallel, so expected cylindrical shell is the volume of, is the solid volume element generated. Solid of revolution, so let's see, when revolve about this y-axis, we get this solid. So the element will also revolve, forming cylindrical shell. Using cylindrical shell method, we have dt equals dx, radius of the shell, so that's the mean radius, that is x minus 0. So from here, so this is x, so x right, that is x minus x left, 0. So we have x. Height, that is y higher, 3x squared minus x cubed, y lower is 0, getting 3x squared minus x cubed. Differential of v is equal to 2 pi r h dt. So getting volume 2 pi integral from a to b r h dt. Getting 2 pi integral from 0 to 3 x, that is the radius, then height is 3x squared minus x cubed, dt is dx. So again, there are limits 0 to 3. So because this region to be revolved runs from 0 to 3. So the integrand is 3x cubed minus x to the fourth. So integrating, getting 3x to the fourth over 4 minus x to the fifth over 5. Evaluating at the upper limit, we get what? 243 over 4, and this is 243 over 5. Lower limit is 0. So multiplied by 2 pi, so the volume is what? 243 over 10 times pi, or cubic units. So again, so this is the volume, 243 pi over 10 cubic units. What about if the axis of revolution is x equals 3? So same region to be revolved, the only difference that it is revolved about this line. So the appropriate element is still vertical. So when this is revolved about this line, so this is the solid generated. The element will generate a shell since this is parallel to this axis of revolution. Okay, so that's the shell. Using cylindrical shell method, differential volume is 2 pi r h dt. So r is equal to, so this is 3 minus x. So this is, from here to here is x. So anywhere on this y, on this element, distance from this is x. Okay, so this is 3. This is 3 minus x, giving the mean radius r. So h is y higher, y lower 0. So y higher is 3x squared minus x cubed. dt dx, because this is vertical. Volume is 2 pi integral from a to b r h dt. So where r is 3 minus x, h is 3x squared minus x cubed. So getting this integral. Multiplying, we get 9x squared, then minus 3x cubed, minus 3x cubed, then plus x to the fourth. Okay, combining this, we get negative 6x cubed, then plus 9x squared here, plus x to the fourth. Okay, then integrating x to the fifth over 5 minus 3x to the fourth over 2. So because this is x to the fourth over 4 times 6, so getting 3 halves. Okay, so then we have x cubed over 3. So 9 over 3 is 3, so 3x cubed. Evaluated from 0 to 3. At the upper limit, we get 243 over 5 minus, this is 243 over 2 plus 81. 3 times 27 is 81. At the lower limit, everything is 0. Simplifying, we get 81 pi over 5 cubic units. So this is the volume of this solid. Okay? So again, guys, hopefully you will learn something about this discussion. I was able to discuss 3 methods of solving volumes of solids of revolution by integration. So namely, circular disc method, circular ring or washer method, and then this is the last one, cylindrical shell method. Have a nice day, guys.